Dear students, this is Professor Dr. Satish Polshettiwar from MIT World Peace University, School of Pharmacy, Pune, India. Today I am going to talk on understanding of theories of emulsion. That is part 2. Part 1 we have been discussed about surface tension and interfacial tension, how the surface tension and interfacial tensions are useful for making the stable emulsion. This is very important now. What are the different theories of emulsion system? Okay, it's nothing but the biophysics system, which is thermodynamically unstable system. Let us begin with this topic. What we are going to discuss a learning objective about what is emulsion, then be familiar with the theories of emulsion. Different theories are being involved while making this emulsion process. Then get knowledge about the main emulsion stability problem. Then learn how to preserve the emulsion. These are the things that you are going to learn during this presentation. Let us begin with this topic. So what is emulsion exactly? Nothing but the emulsion, actually nothing but the thermodynamically unstable system. If we say talk about thermodynamic point of view, this is unstable system because a lot of energies are free energies are involved in that system. That's why it is called a thermodynamically unstable. It's a heterogeneous system. It's made up of two phase, that is oil and water phase. Then it's also called as biphasic system. Okay, emulsion is biphasic system consisting of two immiscible liquid, one of which is finely subdivided, that is dispersive phase we usually call, uniformly distributed throughout the dispersion we call as medium, that is we call as continuous phase. That is nothing but the emulsion. It has been divided into different types, okay, depending on the particle size. A global size mostly we see over here. A global size is depending on the global size. It has been classified into simple emulsion. It could be oil in water or water in oil, having the global size 0.1 to 100 micron. Another type of emulsion is multiple emulsion. It could be multiple, that is three phase system where oil, water and oil system. Oil is your continuous phase. It could be water is continuous phase, water, oil, okay, water, oil and water based system. Another, the advanced version of this system is that is depending on particle, that is global size. It has been reduced by using technology. Okay, we use homogenizer sonication system in order to break down the global size. By using sonication method we can bring down 0.25 to 25 micron, because you all discussed in my previous video that reduce the particle size because surface area of the larger globals having more free energy, also more. If you want to bring down the free energy negligible level, then you have to always use surfactant. You have to reduce the particle size, we call as global size in this case. That global size can be reduced by using the method that is we call a sonication method. We can use probe sonicator for that, where we can reduce the global size and we can bring down at this 0.25 to 25 micron, and this system we call as a thermodynamically stable system. But these two systems, that is your simple emulsion and multiple emulsions, are thermodynamically unstable systems since the free energy surface area of the global size is more, that's why. But this micro emulsion, which is the global size 0.25 to 25 micron, is always stable. And nano emulsion, another system where we maintain the particle size, a global size 50 nanometer to 500 nanometer. Here also this system we call as thermodynamically stable system. These two systems are thermodynamically stable while these two systems are thermodynamically unstable. That is we call as emulsion. So best example, your milk. Milk is a natural example of your emulsion. Okay, the milk is nothing but the oat in water in oil emulsion, while butter is water in oil emulsion. This is the best example we can remember how what is OW and W type of emulsion. And OW type emulsion mostly used for external phase. All of you know W type, that is what oil based system is mostly used for external use like cold cream, and OW type, that is we use in vanishing cream, that is mostly used for both the system. OW is used for both the system. This question may appear in GPAT examination. Which type of emulsion is used for both the system, that is OW type? Answer is your water base, where we use emulsifying agents like mostly twin having HLB value 8 to 16. But in case of WO type we use emulsifying agent having HLB value is 3 to 8. That is example span, that is we call as polysorbate esters. Esters are mostly used for as emulsifying agent in this WO type emulsion where oil is best. So just now we talk about this, what is emulsion. Okay, what are different theories of emulsion? No universal theories of emulsification is available because emulsion can be prepared using several different type of emulsifying agents, each of which depends for its action on different principle to achieve stable products. Any theory to be acceptable should explain the following: stability of product and type of emulsion form, whether it is forming OW type or WO type, depending on that, even global size, that depends on that the principal stability is involved, a physical chemical stability is involved. Okay, so now you just take the example over here, A, B, C, D. Here two systems are there. We have one oil and one is water. So oil won't get mixed with your water unless and until you add some surfactant, because interfacial tension between these two phases is very very high. Okay, this is the interfacial tension where the we call as the unlike molecule adhesion, that is strength of adhesion is very very high. That's why they have the adhesion, force of adhesion. Okay, so because of that won't mix. So unless and until you add some emulsifying agent, then it will mix. Okay, like this in third system, emulsifying agent stabilize the emulsion, because we want all the globules dispersed evenly distributed in your system. So it is happening by adding this proper emulsifying agent. You have to select the emulsifying agent depending on the HLB value that we have discussed in my previous video. You go through my previous video where you understood the HLB scale, how it is useful to make the stable suspension, emulsion, even suspension also. Theories of emulsion, there are different theories, but among these the three theories are very important: the oriented wedge theory, plastic interfacial film theory, and surface tension interfacial tension theory. Other theories also there, but that is not they are list we call as useful, but these three theories are mostly used. Okay, because there is no universal, just now we talked, there is no universal theory of emulsification. So there are three main theory, that is we call as surface tension theory. As we discussed, if you want to mix oil with water, it won't get mixed because of interfacial tension. We all discussed interfacial tension is very very high in this two phase between these two. Okay, because of that force of adhesion, unlike molecules, the strength of this molecule is very very high. Okay, that's why we have to reduce the interfacial tension by adding some surface. Want to make OW types emulsion, that is oil base, oil is your we called as dispersed phase, and W is your water is continuous phase. Then you have to select the proper HLB value, emulsifying agents, that is called as emulsion, having as per HLB value we select 8 to 16. We have discussed HLB scale. 8 to 16 have been used as an emulsifying agent for making the OW type of emulsion. Mostly twins are used, nothing but the polysorbate. We use twin 20, twin 40, 60, twin 80, depending on your stability or depending on your optimization process. So you have to always lower down the surfactation one has to make the a stable emulsion. Another theory is oriented wedge theory. Okay, you all of you know the missile is going to form. The globules have always have directions to upward. The surface tension is more. Interfacial tension also very 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 high, because we want to reduce the resistance force. So for that we can give the layer on that particular globules in order to bring down their surface energy at lower side, so as to make them more stable. That is we called as oriented wedge theory. That's why it's called oriented wedge. You have to just bring down downward force. You have to make them we call as zero force. The force of attraction and force of that things you have to always make zero. Then and only it will make your system stable. Another is interfacial film theory. Here film of emulsifying agent prevent the contact and coalescence, that is the major problem of physical instability in suspension of dispersed phase, that can be bring down. The major role is your emulsifying agent. The selection of emulsifying agent is very very important in case of making any stable emulsion. So you have to think about that HLB value. Always you have to take into consideration the HLB value. So the first theory is a surface tension theory, where we use this substance emulsifying agents as an emulsifier, a stabilizer we could say. We lower the interfacial tension of two immiscible liquid. Look at this. Now if you want to mix this oil could be fixed oil, it could be volatile oil, it could be mineral oil, it could be oleoresin, because there are four types of oil we are being used in pharmaceutical purpose. Fixed oil like vegetable oils we use. Okay, then we use volatile oil like turpentine and all, mineral oil, that is paraffin oil, then oleoresin. They are the four types of oil. So depending on that you have to select the proper ratio of the water and gum. Okay, that is emulsifying agents. That is mostly we use 4:2:1. That is in order to make primary emulsion. Mostly we take 4 in case of fixed oil, 2 and 1. In case of volatile, 3:2:1. So only 2:1 is common. Only you are going to change the oil pattern. If it is fixed, then 4, volatile 3, mineral 2, oleoresin 1. Okay, and 2:1 ratio is common, that you must have studied in emulsion chapter. Reducing the repellent force between the two liquids, diminishing the each liquid attraction of its own molecule. Thus, surface active agents facilitate the breaking of the large molecule, a globule, into smaller ones, which then have a lesser tendency to reunite and form a coalescence. That is we should learn. Okay, we should understood, because surface tension of the particle you are going to reduce by adding surfactant, proper surfactant. It could be anionic surfactant, cationic surfactant, amphiphilic, non-ionic surfactant. But mostly non-ionic surfactants are useful because they are mostly less toxic in nature. Okay, because we are administering through internal route in case of OW emulsion. In case of WO, we can give it to external routes in case of cold cream. Okay, this is we are just always we have to bring down the zero force. This is the zero, the force. Okay, and work done should be zero. resistance should be 0. Okay, resultant force should be, you have to make always 0. For that you have to add a surfactant. This we have discussed. Okay, surface tension means you have to reduce the cohesive force among the liquid molecules so as to bring the molecule like this. Okay, water molecule below surface, then and only it will be stable. You want this B particle, not A, because A is having a lot of force. Surface energy is very high. You have to bring down surface energy so as to particle uniformly distributed in your system. This is like the system. Okay, you have to bring this missile. Okay, that is critical missile concentration, you must have understood. Then another is oriented wedge theory. I assume the monomolecular layers of emulsifying agents curve around the droplet of internal phase of the emulsion. It is based on pre-assumption that the certain emulsifying agent orient themselves about or within the liquid in a manner reflective of their solubility in that particular liquids. Because many molecules of substance upon which this theory is based, example soaps, have hydrophilic and water-loving proportion and hydrophobic as well as water-hating portion. These molecule position orient themselves in each phase. Okay, like this, having both hydrophilic and lipophilic, so it will orient like this. That is called as oriented wedge theory. Then plastic interfacial film theory. It is placed the emulsifying agent at the interface between the oil and water surrounding the droplet of internal phase as a thin layer. It is going to form a thin layer on that globules so as to bring a proper contact. It will prevent the contact and coalescence, the disbursement. It will repel each particle, each globule get repel each other because of formation of film of that surfactant. Okay, this is the theories of emulsion. Again, interfacial film, it preventing the coalescence of droplet by two methods: formation of rigid film and formation of electrical double layer. We discussed in that DITA potential. Okay, in my last video you might have gone through my DITA potential, how DITA potential is important because DITA potential it will not bring the particle together, it will always repel, it will keep that particle away, the globule away from each other so as to maintain that particle, that globule in uniformly distributed in your system. That is the importance of DITA potential. DITA potential is very, very important. You have to always keep high DITA potential so as to bring the molecule a separate properly, a separate entity. This film we have discussed. Okay, it could be monomolecular, multimolecular and solid particle. You could see here, this is the particle. Okay, these are the globules, how it is oriented. Okay, in monomolecular and multimolecular and solid particles. Okay, there are three interfacial films. It could be. Then emulsion stability. The final product is considered stable when the following criteria were met: absence of the creaming and maintenance of elegance with respect to appearance, order, color, other physical properties, agglomeration of the internal phase and separation from the products. Physical instability is because of coalescence. Okay, for that you always maintain the globules far away by keeping the high DITA potential. We can add a surfactant, emulsifying agents. Okay, in order to we can reduce the particle size or globule size so as to maintain that globules properly in your system only. Okay, this is a good emulsion where the particles or globules are evenly distributed and they are repel each other. Okay, you have to maintain that. You have to add such a emulsifying agent that will form this. You have to avoid all these four problem: flocculation, breaking, creaming and coalescence. So flocculation can be prevented by reducing the particle size, the globule size. One can reduce the globule size, your problem will be, flocculation problem will be resolved. Breaking of emulsion is formed because of, if you are not adding any emulsifying agent, then emulsion get break. You have to add a proper emulsifying agent by considering the HLB value. HLB value is very, very important. You always, whatever the HLBs required HLBs, you have to calculate by taking into consideration into all the HLBs values of all the your components. What is the oil you are adding, what is the drug you are adding, you have to take into consideration and you have to calculate the required HLB. I hope you must have gone through the previous video where I explain about that things. These are the references that I have been referred for making this presentation. Thank you very much for listening me, and I hope you must have understood. Okay, so in order to make an emulsion, one has to understood the surface tension. What is surface tension? It is nothing but the strength between the like molecule, that is strength of cohesive force. And what is interfacial tension? It's nothing but the strength between unlike molecules. It's called of adhesions. Okay, that's why in order to mix the water into oil, always you have to add some selecting proper emulsifying agent, a surfactant. Okay, so for WO type emulsion, we mostly use surfactant having HLB value 3 to 8, that is span. Example of WO type emulsion is cold cream. In OW type, if you want to make OW type, always you have to choose the surfactant having HLB values 8 to 16, that is more hydrophilic. Example is twin, that is polysorbate. Okay, an example is vanishing cream. And theories, we have been explained the theories of emulsion. Mostly the interfacial tension theory is very important. Okay, I hope you understood all. Thank you very much, and visit my this video channel and subscribe it.